Testing 1 2 3. Testing 1 2 3. Sorry about the wait, guys. Testing. We adjust the mic a little bit here. They're ready to come online finally for a new day of streaming. Yo, what's up? Welcome back to Vencabot. Intro to Python action. My name is David. We're trying something a little bit new today here, guys. Let me actually move some things around here. I had this actually. I need to move my mouse actually. 1 second, guys. We're trying something kind of new today, insofar as this is an episode outside of our usual seasonal schedule. Right? Not really seasonal in any case. But let me drop this down here. Yosh, right on top of my noodle there. And we can probably move this over a little bit. It's probably okay there anyway. Yeah, so normally here in Intro to Python, we do 6-episode seasons, right? We kind of make a game over 6 episodes. We start off being totally basic. What is a program? How do I download Python and install it and run it? What do I need to make programs? Writing our first few lines of code and how to read it, etc. As the streams go on in those 6 episodes, we end up with a sort of a very simple example game that hopefully by the end is at least kind of fun to play with. If maybe only to program either way. In any case, usually they're pretty fun, right? Usually pretty fun by the end. Yo, Signap knows the deal. Sha la 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 dee da. He's a man that loves him some classic music. Anyway, so today we're trying something new, right? We're not going to be in this 6-episode rotation right now. Instead, we're going to be taking like a little side quest where I want to talk more about object-oriented programming and mutability. This is usually reserved for episodes 5 and 6 of our seasons, the most complex that we ever do. And so it's not really suitable for total beginners who have never seen a program before in their lives. Right, but it is something that I think is worth talking about for people that are trying to break into that intermediate level of programming, right, from the very beginning level. So let's talk a little bit, first of all, what do I mean by object-oriented programming and mutability, right? So first of all, when we talk about, excuse me, let me get a capital letter there. When we talk about data in our programs, we're talking about the information that we're saving and moving around, manipulating, using, calculating, to make our program work. Right. For instance, in a video game, the data might be things such as the character's position, right, or their ammo, right. And as the game goes on, these values are going to come into play, and they're going to change. Right. In the case of a character's position, it's used to know where to draw the player character, or what environment to draw around them. But that value is also manipulated, right, whenever the character wants to move. The ammo is the same thing, right? Now, the ammo data is the same. It's used when we want to show the player how much ammo they have. But it's also manipulated every time they pick up ammo or fire a shot. So, usually on episode 1 of our seasons, we talk about how programs are made up of essentially 2 things: data and operations, right? The data is the information, and the operations are, what your program does to and with that data. That's pretty much what a program is, right? It's kind of abstract, but if you look at it a certain way, you can definitely see how that would be the case, right? Today, we're talking a lot about data. Right, because we're looking at some of the most complex aspects of how data is stored and accessed and manipulated within a simple program. Right, actually, break a line there. First of all, what kinds of data are we talking about when we're thinking of simple programs? Right. Well, Python and most other languages come with a bunch of data types built in. On top of allowing you, I'm going to make a list here, right? Built in, such as numbers, and text, or true or false values. On top of, let me actually go back here. On top of allowing the programmer to create their own more complex types of data, such as player state, or you might have something like driving history, or in another case you might have student loan balances. All those things are types of data, right? They're all complex kinds of data. They involve maybe even more than one piece of individual data, but they're combined into one big piece of data. Right? So, a lot of this data is going to change, be altered, or be mutated. Right? When data is designed to be mutated, which it means or altered, changed. We say that it's mutable. Right? It can be mutated. It's mutable. On the other hand, some types of data cannot be mutated. They can only be created and destroyed. Right? In these situations, if you want for data to apparently change, you have to destroy the old value and replace it with a new value. Right? Data like this is called immutable because it cannot be mutated. So, what is the difference between taking an existing piece of data and mutating it versus taking an existing piece of data and destroying it and replacing it? Right. On the surface level, these seem like the exact same idea. Right? Like, if you end up with something, if you have an old value and you end up with a new value, why does it matter if you just simply change the old one to the new one by mutation, or if you just destroy the old one and replaced it, right? What's really the difference? The difference is all about how data is saved, stored, and accessed. In other words, it has everything to do with how the data is used. And that's why it's a bit difficult to get a grasp on at first. Let's look at some examples. Right? I'll go over here to our programming side now, right? So you guys know that if I put a pound sign there, or a hashtag or a number sign, that means it's a comment line, right? Python will ignore this line, right? So I can type in regular English. Right? So I say here, my number equals 1, then our first line of Python code is my number equals 1. Right? The comment line isn't actually read by Python. I can actually run this and watch. There, my line's 1. I'm just going to print here, let's go down here and say print my number. This is okay, right? Glorious Python. What's up, dude? Welcome aboard, Ryan. So I run this code, you're going to see here that it just prints off, 1. Right? However, if I take away this pound sign here, now this line is not a comment anymore. Now it's actually a line of Python code. And as you might imagine, this is not a good line of Python code. It's actually in English, right? It's not in Python, it's in English. So if I actually try and run this, we're going to get a syntax error, or some other kind of crazy-ass error. Yes, the invalid syntax, right? So basically, you can put start lines with a pound sign, and that way we can type in English in our actual code to kind of leave notes for programmers or for ourselves, right? Other programmers, etc. Welcome aboard, guys. Today we're talking about mutability and object-oriented programming again. It's a sort of aside from our usual schedule for Intro to Python. We're kind of doing like a sort of side lecture about mutability and why it works the way it does, and how you want to take advantage of it. So let's get rid of this and get rid of this comment, in fact. So let's make a note here. Right. First of all, when you assign a name to a piece of data, that's all that you're doing. Right. This is a bit difficult for beginners to comprehend, who want to think as of their variable as being a sort of changeable object in itself. That's why in Python you don't hear the word variable as much as you hear the word name. Right. So let's make an example of that. Right. Let's say here we'll say my number equals 1. Okay, then we're going to say down here second number equals 2. Print off my number plus second number. That seems like a day one Python stuff, right? But it's for a purpose here. We're going to talk about naming and mutability and why. We're talking about some more complex aspects of it than we do in Intro to Python episode 1 usually. Run the module. Because we got a 3 gets printed off, right? Prints off 1 and 2 becomes 3. Because we have this 1, which is named my number, and this 2, which is named second number. Right? So we have that right there. Prints it off, prints off 3, as you'd imagine. So what we're doing here is this little equal sign here. It's the assignment operator. And it assigns this name to this number or this value, whatever the value might be, right? We're assigning a name to a value. However, here's where things get kind of interesting. If I go down here and say, my number equals 5, and save that, what's going to happen? You guys are definitely, at this point, you're intermediate level programmers. You know what's going to happen, right? It's going to print off 7, obviously. But what's interesting is that now there is no way to access this number. It has been garbage collected. It's gone, right? When we name a value, we can access it every which way but loose. Right? We can access it anywhere we want. But once we reuse that name, that first value is gone. We cannot access it anymore. There's no way for us to reach it as a programmer. It's outside of our reach, right? So we have to kind of be careful how we name things sometimes, because if we name things the wrong way, we can actually lose track of previous values that previously had that same name. So here's where things get conceptually interesting. I'm going to run this code just to run it, right? So now we have 7. We cannot access this number anymore. It's gone. The 1 we made here with the integer literal, right? 1 is the integer literal 2. 2, here's another integer literal 5. This number we made right here is gone now. We can't access it anymore because we reused its name. Now, what's interesting about this is that you'd be forgiven as a beginner programmer for conceptualizing this process as changing the 1 to a 5, right? You might think that because your equations that include the name my number are still treated and running exactly the same way as they did before. It's just that, the value of my number has changed. That's what it seems like. But that's not strictly the case, right? That's not strictly the case. What we've actually done is create a whole new integer and, incidentally give it the same name that a previous value used to hold. I'm sorry, I keep thinking this is a vim. So what we've done here is, although this print line behaves exactly the same as it used to, right? This my number here is a whole new my number, right, than it was before we had this line here, right? It just so happens that the name is the same. Hey, welcome aboard, Zanzu. Now, this man was yeasting way before the stream even started. He's here trying to get me to get here on time. I'm over here in the shower feeling good as a mug. Guys, I smell amazing right now. Trust me. I wish you guys had smell-o-vision. So, this is, again, let's I make a note here. what makes this so difficult to internalize is that as far as the code is concerned, as far as we are concerned, for the most part, there is no difference between changing a 1 to a 5 and replacing a 1 with a 5. They're to follow Let's Be Honest. Yeah, let's be honest, dude. I think you followed once before. Welcome aboard. Thank you for the refollow if that's the case. Might be wrong about that. If you have any questions, let me know. With a 5. Right? So, I just want to reiterate that when you reuse a name, that's exactly what you're doing. You're reusing a name. You are not changing the value of that name. You are simply taking a new value and giving it a name that used to belong to a previous value. Right? Anytime you see this equal sign, that's what you're doing. Right? Anytime you use the assignment operator, equals, you are assigning a new name to a value. Right? If that name had previously been in use, then that value is no longer accessible by that name. Right? You can only have one value per name, and names can be and often are reused. In this case, we're just reusing a name. Right? We have more comments here than code. I hate when that happens. Anyway, so this is our example here where, actually I'm just going to copy this and put it over into our notes. Right. So that happens every time you use the assignment operator. There we go. Sound says, let me take a deep breath and see, dude. It's that fucking Gillette, bro. The best a man can get. That deodorant. Okay, so we learned, a little bit about what it means to name a value. Right? It seems so simple, and we usually make it very simple on Intro to Python day 1. But there is more going on under the hood that can cause you problems later on and make things a little bit more confusing when you talk about mutability. Right? So anytime you see this equals symbol, you are assigning a new name to a value. Think of the follow Mrs. Mr. 2. Interesting handle there. Mrs. Mr. 2. Something like an imaginary friend name from back in elementary school. Right? So let's look at where this immediately causes problems. Right? I'm going to get rid of all this code here. Hey, Rusted Gold. Welcome back, dude. We had so much fun last night, bro. All right. So, let's talk right away about why it's important that we understand the way that naming, I'll say that name assignment, works in Python. The first problem that a beginner is going to run into with names is in the case of function arguments. Right? Let's make a function that takes some arguments. You guys know my favorite function, right? My favorite beginner function. It's like sum, right? We're gonna make a function here, define a function called getSum. Come get some. We're gonna give it a first number and a second number. That's not a good example. What's a better example of how to talk about mutability, right? Let's say, how about we make like a name changer, right? Let's say definition name changer, right? We'll give it, your birth name and your way cooler nickname. Right. And we're going to say here, print your birth name was plus birth name. Right. And then we're going to say here, birth name equals way cooler nickname. And we're going to say here, print your new name is plus birth name, right? So you guys know what's going to happen here, right? We're going to enter in like, David and Vencabot or whatever. And so say your birth name was David. They're reassigning the name birth name to way cooler name, right? And we're going to say here, now your new name is Vencabot, right? It says here birth name, but we just changed the way this name was assigned, right? We assigned this name, birth name, to our way cooler nickname. So we're actually going to print off here something different. Let's go see how this works now. Right? So I'm going to say here, my birth name equals, David. And, my nickname equals, Degowd. You guys know me. We're going to say here, name changer, run the name changer on my birth name and my nickname. Right, there you go. What's going to happen here? Watch. You guys know what's going to happen, right? Run it. All right, it says here, your birth name was David. Your new name is Degowd. Guys, come from now on, please. Refer to me as Degowd, or I'm going to get pissed off. So what happened inside here was we got two arguments, birth name and a way cooler nickname. We printed off our birth name, right, which we got in the first argument slot. And then we reassigned this name, the birth name, to this new value. This value came in on this argument, right? Second argument. The way cooler nickname. So now, although this line... Actually, I'm going to make it even simple. I'm going to do it like this, right? Say your name was and your name is. Right? So let's run this again so I can just kind of demonstrate this. Okay, so your name it was David. Your name is Degowd. Right? So basically, although these two print statements look exactly the same, right? They look so similar, but the value of birth name, this name is now pointing to a different value, right? Interesting. Okay, that's great. But here's where things get confusing right off the bat. Okay, so although we fed in a birth name and we changed the value of it, if I now print off down here, my name is plus my birth name, save it and run it, it still says my name is David, even though I just changed it to Degowd. Right? So inside here, I supplied the argument in the first slot and an argument in the second slot. And it changed the name from the first slot to the value of the second slot. Right? So how come my name is still David? I fed in my birth name in that first slot. Shouldn't that have gotten changed over to Degowd? Well, the answer is no. The answer is no, right? Because as soon as I made this assignment right here, that equal sign, we made an all new name, birth name, and gave it a value, but this value, although it looks the same as this, they're not the same thing. Right? We have reassigned this name. We're not changing anything. We destroyed something. We got rid of the old name and replaced it with a new one. Trying to mutate globals threw me in Python when first learning, huh? Yeah, exactly. The globals. Trying to mutate, anything, right? Unless it's mutable. So we have this problem here where, we have these names are being reused, right? Let's make a note here, right? Whenever you reuse a name, you are not changing anything about the value. You're just, taking that old name and giving it to something else. Right, so let's go over here. I wish I had an even better example. Right, there are so many better examples that we could make use of. I'm trying to get into that mind state where I was first so confused by this. Okay, well, use another example, right? Let's use an example of scope. I'm going to make a copy-paste this. Talk about scope a little bit. Because that's where things get really weird, too. I'm going to upload these notes, guys, to our GitHub. If you guys want to review these later. Okay. Let's talk about scope real quick. Scope. Let's talk about scope and how that affects our understanding of names. Right? Today we're talking all about names and how they can be more confusing than they first appear on, Intro to Python episode 1. Right. So let's do some scoping, right? Let's talk about, we're going to do function, right? I'm going to say here, define a function. We're going to say, make friends, person 1 and person 2. We're going to print off person 1 plus and plus person 2 plus are now friends. Not friends. Holy shit. They're now friends. Right. Sweet. Okay. That's probably not the best example, actually. Let's not do that, right? We need something. We need to do some math, basically. But how can I? Let's. How about we just make a little RPG, right? So things get pretty clear. Let's just say. Let's say here, def attack player, right? We'll say here we'll give it a player HP, and we'll give it the enemy attack power. Right, there you go. So now we can say here, player HP equals whatever it was minus enemy attack power. There you go. Okay, so it's going to lower their player HP, right? Now we go down here and we say player HP equals 10. Right. Then we can say here monster, enemy attack power equals 5. We'll say equals a 7. Right. Now we can say here attack player HP, enemy attack power. Now let's actually make a little print statement here, saying, print the enemy did plus, string version. This is going to be an integer, right? String version of enemy attack power plus damage, right? Now we're going to go down here. We attacked the player, right? The player's been attacked. Now let's print off, the player has plus the string version of player HP plus HP remaining, right? Let's look at this code right now. Okay, before we even run it, let's look at it, right? We have a function up here that takes two values, player HP and enemy attack power. It reassigns the name player HP to whatever it was minus the enemy attack power. So if you had 10 HP and the enemy had 7 attack power, then now player HP equals 3, right? Then it prints off the enemy did so much damage. Okay. Here we have player HP equals 10. Enemy attack power is 7. We attack the player right here. We supply the arguments as specified, right? Player HP and enemy attack power. We print off how much HP the player has remaining, right? We should have 7. Let's run it. Oh, fuck. The player has 10 HP remaining. Then we did 7 damage, right? The math happened right here. This math definitely happened. So why, at this point, after the attack, does the player still have 10 HP? This is a classic problem for beginner programmers when they try to understand mutability, naming, and scope. Right? So basically, the problem here is that this player HP value here has the same name as this value and this value. But this number we're making inside of here is a whole different number, right? A whole different integer. And this value here, this name, player HP, only exists within this function now. It's the same exact name as this name, right? But it exists in a different scope. This scope here, this far left, like no indentation scope, is the main scope of our program. Right? Whereas this little function here is a subscope. It exists inside this little indented space. It's a code block, right? In this case, it's a function. It's a function scope. So any name you create inside this function exists only inside this function. Right? And yes, it's the same name as this one, but we are still assigning it. It's a brand new name. Right? Anytime you assign, you're giving a new name to a value. Even if it's the same, even if you're reusing it, you're still it's not the same name as it was. So because we're assigning this function here, this variable, this name, only exists inside of this function. So even though we use the same, the same words, the same characters, it looks the same, we cannot access this value outside of the function because it's scoped into that function. Right? This is exactly why we have to use return. Right? We can return player HP to get a new value out of there. Right? We talked, in Intro to Python episode 2 or 3 usually about how functions take data in through arguments, and they get data out through return. Right? Otherwise, you can't get data out of these things. Because anytime you mess with data inside of your function, or you make your own variables inside of there, they don't exist outside of that function. Right? That's the problem here. So yeah, we made a value called player HP inside of our function. And sure, we did some math onto it. But even though it's the same name, player underscore HP, it doesn't change the fact that in the main scope, the same name still means 10. Right? In the main scope, player HP is 10. And that has never changed yet. Right? Inside of here, maybe it equals 3 right now. Right? It equals 3 right there. I can actually print that off. Right? Let's print off a new value. We'll say print off, inside of this function, player HP is plus the string version of player HP. Right. Now here we can say, get rid of this line. We can say, print outside of the function, player HP is string version of player HP. Right. So it has the same exact name, right? Player HP, but in 2 different scopes. One is inside this function, and one is inside the main block. Right, let's run this code and see what happens now. All right, so the enemy did 7 damage. Inside of the function, player HP is 3. Outside of the function, player HP is 10. So it's the same exact name, player HP, but depending on the scope, it has a different value. That can be very confusing. In fact, make a note over here. Let's make a note right here, in fact. So go down to the bottom here. The value player HP has 2 different values. I'm sorry, the name player HP has 2 different values based on where it's being used. Right? I'll say based on the scope of where it's being used. It has one value at the attack player function level scope. It has one value in the program's main or global scope. Right? So where you're using that name is, it depends on what value you're going to get back. Right? This is why you'll often see programmers being careful about how they reuse the same name in different scopes. Right? It can get kind of confusing. That's really all there is to it, right? If you use the same name for variables in different scopes, do it at your own peril. It can make sense to do it a lot of the time, but keep in mind that this is not the same value, right, as this. It has the same name, but it is not the same value. What's up, Philip? Welcome aboard, man. Says, yo, Holmes, what's up? So, again, we can return data, if we want to raise, I'm going to say elevate values out of their limited scope, we can use the return function, the return keyword. Right. So let's go do that. Right. And so we'll go say here, attack player, return player HP. So here we have done some math, and we've assigned the value to the name player HP. Right. Now I'm returning that value back out. Now you guys know, if you guys have done Intro to Python episode 2 or 3, that when you return a value, now we can treat this this function call as though it was a value. It returns the value back out, right? Let's say here, you know, player HP equals the value that's returned by this function. Right? So now we are reassigning the name player HP to a new value in the global or main scope. Right? So now this should all work just fine like you'd expect. Just watch this. Run this. Blah, blah, blah. There you go. So now we say here, the enemy did 7 damage. Inside of the function, player HP is 3. Outside of the function, player HP is 3. The player has 3 HP remaining. Right? Because now we have taken this value, we did some math in here, right, inside the function. And the result of that math is now being returned out of the function. And we are assigning that value back into a name that exists in the global scope. I know it sounds like a bunch of gibberish, right? But you guys get the idea, more or less. We have this 2 different scopes inside of a function and inside of our main program. And in order for us to have the name player HP be equal to the result of some math inside of the function, we have to return that data out of the function. Because we can do as much math, you know, we can do as much math in here as we want. It can essentially never affect the outside world. You know, outside of mutability, which we're going to talk about shortly. Unless we, you know, find a way to elevate the values out of this scope, you know, using return. So we were doing some math in here, right? But it doesn't really matter unless we return the value out. Because this scope here is limited. Once this function ends, all this shit goes away. It just basically never happened. I guess garbage collected, as they say. It's we can't access it anymore. But if we return the value back out and assign it a name in the global scope, now we can use it elsewhere in our program. Right? Kind of cool. So, the problem that a lot of people have with functions as beginners is understanding that because 2 values have the same name, that does not mean that you can use them the same way anywhere in the program. Right? They might have the name player HP in both places. It can have it in 100 places. But it doesn't mean that whenever you change this value here, you can use that same name elsewhere and expect for the value to have changed. Because, you know, this value just goes away when the function ends, unless you return it back out. Okay, and then you reassign it right here. Or we could assign this any name too. We could assign this, you know, whatever name we want. Right? Doesn't really matter whatever we call that. We could just call this here, you know, whatever name we want. We can call it the same thing right here, whatever name we want. Okay, run it. Still should work exactly the same, right? Yeah, all right, 3 HP remaining. So even though we have this player HP value right here, which is 10, player HP is 10, and we've reused a name inside this function, right? It's a different scope, right? So this is a whole different player HP value. And we returned it out. It was called player HP inside the function, right? We're returning out player HP. We assigned it right there, right? This is the value we're returning. But when we actually capture that return value and we assign it this name, we assign it the name, whatever name we want. We don't gotta call it, we can call it whatever, right? We don't have to call it player HP. We just are assigning a name to the value returned by this function. Right? All these names inside this scope are meaningless now that the function has stopped executing. Right? As soon as this line is over, it doesn't matter. All these names don't mean anything anymore. Right? They only exist inside the function when it was running. So we just decide to call it whatever name we want. So in fact, we also say, now we can say, you know, print, you know, the name, you know, because it was never reassigned, right? Because it was never reassigned in the global scope, player HP still refers to plus the string version of player HP. Right? See what the point I'm trying to make here? Here we decided to call the new value whatever name we want. Right? So the name player HP was never reassigned in the global scope. So what does that mean? It means it still is equal to 10, right? Let's run it. Yeah, it still refers to 10. Right, so here we say that in the global scope, player HP equals 10. We ran a function, and we supplied player HP as an argument, so we supplied the 10 as an argument. And inside of this function, we just so happened to call that value player HP. Right? It's the same name, but it's a different circumstance, a different scope. Right? So it's totally incidental that it's the same name. It doesn't matter. Here we reassigned that value, again, to the same name, player HP. And we returned that value, right? It's called player HP right here. We assigned that name inside the function and the scope. But once we returned it, we took that return value and we assigned it a name, whatever name we want. In the global scope, the name player HP was never reassigned. We never see this equal sign here in the global scope with player HP on the left. We have never once, after this, said change the value associated with this name, right? And here we did, but it's a different scope, so it doesn't matter. So down here we see that outside of this function, player HP still refers to 10. Crazy. What's up, dabs and cabs? Welcome aboard to mTOR. Life's treating me pretty well, dude. Having a good time today, talking about naming in Python. The more complex aspects, the things that, episode 1 of Intro to Python, I don't really talk about that much. Like why names mean what they do. We're talking about scope, we're talking about mutability, we're talking about all these weird things with Python names. And we talk about names, we're talking about variables, right? Again, in other languages, you hear the word variable tossed around a lot. In Python, to make things more clear, we don't treat it as though it were its own thing, a variable. We instead say that it has a name, right? The value has a name. Anyway, so let's grab all this code here. This is all part of our notes. And we're going to add this to our notes as we go on with making some examples, right? So now, let's look at how naming, right? Go up here. So now, let's look at how naming and scoping impacts the way that we use data when that data is mutable. Okay, this is where things get even more weird. But if you guys give it a few minutes, you guys can understand it and hopefully internalize it. At the point where I'm at right now, after programming for 20 years, it doesn't really bother me anymore. In fact, it seems totally natural, and you can use it to your advantage even. We're gonna say here, def, add David to list, right? Some list, right? We're gonna get a list here. We're gonna say here, some list dot append David. Right? There you go. So we're gonna say here, first list equals Kenny, Jonathan, Cameron. Right? We're gonna say here, add David to list, first list. Okay, sweet. Now we're going to print off first list. Save it. What's going to happen here, guys? Well, we see here that we gave this name first list to this list. And we gave this list as an argument to this function. And inside this functional scope, right, the function scope, we made a change to that list. Right? So down here, from what we learned last time, first list should still be Kenny, Jonathan, and Cameron, because it has not been changed in the global scope. Right? The global scope, we defined it like this. Inside the function scope, we use some stuff to it, and here we print it off in the global scope. So it should equal, those three guys, right? Watch. Run it. Easy mode. Easy. Holy fuck! No! No! David! But it never changed in the global scope. It only changed in the functional scope. Right? We just got done learning right here. Let me scroll up. Right? We can change player HP in the functional scope. It doesn't affect the global scope. It only affects the functional scope. Right? Player HP was still 10. We changed it to 3 inside here, but it's still 10 in the global scope. How come over here now, we gave this list to this function, the function did some stuff in the functional scope, and then in the global scope, the change is still reflected. That doesn't make any sense, right? Well, it's because we didn't reassign a name. We didn't say here, some list equals, some list, plus David. Right? We didn't do that. Instead, we didn't reassign the name at all. We actually used this append method. Right? Whenever you make a new name inside of a functional scope, you cannot use that name. You can't use that value outside of that function in the global scope. Right? We talked about that. But in this case, we are not assigning a new name to anything. We are instead calling this method, append, on this list. Right? So we're taking the list that we got as our argument, and we are calling a method on that list, append. So although the names, see, I want to make that note, right? Make a note down here. This is where things get confusing at first. Right? The names inside of a function are scoped. Right? The values that you get as arguments are the same values that exist in the scope where the function was called. Right? In this case, the global scope, the global or main scope. It's just that the names don't necessarily carry over between scopes. So I'm going to go even further down here. In the case of our player HP example, we were reassigning the name player HP to an entirely different integer within our function. Therefore, that new name, even though it was the same as a previous name, and that new integer were scoped to exist only within that function. In this case, we're taking a list as an argument, and just as in the case of our old attack player function, the value of that argument is the same as the value of what we got in. Right? The difference is that integers, like HP, are immutable. Right? We did some math using that number, but in order to get a new number from that math, we got to make a new number. A list is mutable and has a method, append, which can add items to that list. So right up here, guys, we took the list we got and we added David to it using its method, append. That's why in the global scope, that change is reflected, right? Because it is still the same list. Just like over here, let's go over, actually, it's over here now, right? Over here, we fed in player HP into this function, right? Player HP equals 10, right there, attack player, player HP. So right here, it is the same 10. This right here, this value right here, is the same 10 that we created right here. The difference is we cannot change that 10 to a 7. We can only use that 10 to make, we cannot change that 10 to a 3. We can only use that 10 to make a 3 using some math. So here we have a 3. Right? Here it was a 10. And now player HP points to a 3. We made that 3 from subtracting 7 from 10. However, it is not the same number that we got here. Here we got a 10. Right? We got the same 10 we put right here. right? We got a 10. We used that 10 to make a 3. So this value, player HP, is still 10 in the global scope. It's always going to be 10 until we reassign it in the global scope, because that 10 can never be changed to anything else but a 10. It's immutable. Once you make the data, you cannot change it. You cannot mutate it. Right? So although we've used the same name inside the function here, this name, player HP, is now pointing to a 3, and both that 3 and that name are both scoped into the function. Right? That 3 was made inside the function, and the name was made inside the function, even though it's the same name as we used elsewhere. That's all scoped to the function. But over here, we have this list, right? And we didn't use that list to make a new list. The list is mutable. It can be changed. We used the append method of that list to change it, right? We did not reassign any names. There is no assign. There's no equal sign here, right? There's nothing like that. No names were reassigned here. And furthermore, we did not make any new lists. We just used the list that we got, and we did some stuff to it. That's why here we print off first list. We see that David has indeed been added to it. Now let's compare that, right? Let's compare them. I'm going to copy all this code now. Put it in our notes for today. What's up, Choco Afro? How you doing, dude? Yeah, we don't have any time command on our bot here. Not sure what you're trying to find. How long have we been up? We've been up for about an hour as of right now. Okay, so we have this, this function here. It changes. Let's make a whole new thing here, right? Read all this code here. Now, let's see how this scoping and workflow behaves when we choose a not to take advantage of the mutability of lists. Do the same exact function, but instead of changing the list we have, we're going to make a new list. I'm going to say here, define add David to list, some list. And we're going to say here, some list equals some list plus David. I think that works in Python, right? That's how you do addition. I'm going to print off, inside the function, some list is plus the string version of some list. I think that should work. Right, so there's our little function there. I need to probably get another parenthesis there, huh? All right, so let's go down here now. We're going to say, our list, we'll say first list, right? First list equals Kenny, Jonathan, and Cameron. We're going to say here, add David to list, our first list. Print off first list. All right, let's see what happens here. We'll say outside of the function, right? We'll say outside of the function. Some list is the string version of some list. So we can print it off, right? It has to be a string to print it off this way. Then it's just, I should say, to add it to this list. Okay, so let's save this and run it. I think it should work. Okay, see? So here we say, inside the function, some list is Kenny, Jonathan, Cameron, and David, right? We added David to the list. However, outside of the function, some list is still Kenny, Jonathan, and Cameron, because we did not take advantage of the mutability of this list. We supplied a list as an argument, and we made a new list. When you add two lists together, you make a new list. We called that list some list. It's the same name as before, right? But we did not actually change the list that we got in. This is the list we got in. And we did not change that list. We made a brand new list inside of here. So this list we made inside of here only exists inside of the scope of this function. Right? When the function ends, this name, some list, and the list we made, they go away. They get garbage collected. They're no longer accessible to us. Right? We printed it off while we were here. But now that it's over, this is where the function ends, right? It's gone. And meanwhile, in our global scope, the name first list still applies to this list, right? The one we supplied as the argument, which was never changed, right? We reused a name, sure, but we made a brand new list by adding these two lists, right? So let's comment this code out and make it work again, right? So yeah, this code will change the name of some list to a brand new list and print it off. But it has not changed the first list. Let's go back and make take advantage. I'll say here, let's take advantage of the mutability of our list argument by saying some list dot append David. Right, now let's run this and see what happens. There you go. So now inside the function, some list is Kenny, Jonathan, Cameron, and David, right? Because we appended David to some list and printed off what it was right there, some list. And also outside of the function, some list is Kenny, Jonathan, Cameron, and David. In this line right here, we just commented out, we made a brand new list by adding two lists together. On this line down here, we took our existing list and appended David to it. Right? We did not make a new list. We took the list we got and added David to it using append. Right? So because we're appending to the same list we got in, that means that we're actually appending it to this list, this very list. Right? That's mutability. That means that because lists are immutable, they can be changed using methods, then we can actually supply them as an argument to a function, to a whole different scope. And there's many scopes in Python, but we're giving it to a whole new scope, the functional scope. And inside that function, we can change that piece of data that we got. And that data persists in every other scope because that piece of data is still the same piece of data. Right? In this other case, if I comment this line out and uncomment this line, this is a whole new piece of data, right? Right? Some list plus David, that makes a new list. It doesn't change any existing list, it makes a brand new one. And that list only exists inside of this function because it was created inside that function. It's scoped to that function. Right? So that's really the profound difference between mutable data and immutable data. Right? We can see it right here in these few lines. There's a big difference between making a new list inside of a function and changing the list that we got. I'm actually going to make that note right here. There's a big difference between making a new list inside of a function, using an existing list, versus I'll say here, versus taking the list that we got as an argument and changing that list. Right? Big difference. The difference is a matter of scope. Whenever you assign a name within a function, that name can only be used inside of that function. Whenever you create some new data inside of a function, that data can only be used inside of that function unless you return it out. I love to return it out. Right? It's all about scope. And mutability, right? Immutability. So once you understand how naming works in Python, understand how scope works in Python, it makes much more sense the way that mutability works in Python and other languages. You have to really understand the way scope and naming behave to understand, why mutability works the way that it does and how to use that effectively. So let's look at a very common problem, right? Let's copy this code back out to our notes. Okay. Let's look at a very common problem for beginners and intermediates of all ages, dude. Class variables. Right. So we're going to look at what we know. We're going to use what we know. We're going to use what we know about naming in Python and scoping in Python to look at a problem that you're going to see time and time again. the mutability of class variables in Python. Right? Let's make a class. We're gonna make our class, you know, cool guy. Right? And we're gonna give him a name. We're gonna say definite. Right? He's gonna have a cool guy name. And he's gonna have. We'll just leave it at that for now. Right, cool. So now we can say here, you know, self dot cool name equals cool guy name. There you go. Very simple class, right? That's all that it does. And we're gonna say here, you know, Kenny equals cool guy Kenny. There you go. We have an object, very simple object here. Doesn't really do anything quite yet. Let's just make sure it runs. No typos or anything. It does. Okay, so that's fine. So now let's give the cool guys. You know, all of our, we'll make another cool guy, right? We'll make another cool guy. We'll call him Signopt. He's a cool guy. His name is Signopt. There you go. We have two cool guys, right? Now let's say that cool guys in general. What do the cool guys have? Well, cool guys have cool hair. So we'll say here, you know, has cool hair equals true, right? That's true. So now we can print that off, right? We can print off, you know, we'll print off Kenny dot has cool hair. We'll print off Signopt. We'll print off, you know, Signopt dot has cool hair. Right, that's true. Save it, run it. There you go. So true and true, right? They both have cool hair. So we could put this down here. We could say here, like, you know, self dot has cool hair equals true. Right? We do it on instantiation. Because remember that init runs whenever we make a new object in that class, right? So we're initializing a new cool guy. Make their hair, you know, be cool at that point. But here's why we wouldn't do that, right? Because it kind of confuses our program a little bit. Because all cool guys have cool hair, right? They do. So why have it happen on instantiation when we know that everybody in this class has cool hair? So instead, let's put it here as a class variable and remove it from instantiation. Just to be more clear how it works. Right, this is a default value, has cool hair. In fact, we can even reassign that name. Let's make we'll make another guy here, Vencabot. He's a cool guy. Right. But although the default is true, any object in Python can have its attributes changed at will. So I'm going to say here, you know, Vencabot.hasCoolHair equals false. Fuck Vencabot's hair. He's like, get a haircut, dude. What a scrub. Now let's print off. Well, first of all, print off Vencabot's, right? Print off Vencabot has cool hair. Okay. There we go. Save it. Run it. Okay, so now Vencabot has, you know, doesn't have cool hair. That's false. And both Kenny and Signopt have cool hair. False, true, true. Right? So yeah, I have reused the name has cool hair for Vencabot, but it has not affected these other two guys. Right? Because it only affects Vencabot. We assigned this new name to Vencabot, you know, has cool hair. It replaced the old has cool hair, right? Because Booleans are immutable. So yeah, I made a new name, has cool hair, on Vencabot. And yeah, he already had something by that name, but he just replaced it. However, it didn't replace it for Kenny and Signopt, right? Because they, you know, they still have this value here, their default value. That's all well and good. Here's where things get tricky. Let's say that all cool guys, we'll say, you know, in pockets, they've got sunglasses. They've got a comb for their cool hair, right? They've got a picture of their cool girlfriend. Right? And finally, they have, very importantly, a black wallet, black leather wallet with a chain. You have to have that to be a cool guy. There you go. So they have this list of things they have in their pockets, right? So now all cool guys have cool hair, and they have these things in their pockets. Sunglasses, combs, picture of their girlfriend, and a black wallet with a chain on it. And again, we could put that list here. We could say, you know, self.inPockets equals, you know, some list of stuff, right? But why? Because it's, you know, the default for all cool guys. Right? They always start with that stuff. Here we established that we can default their hair to being cool, but we can also change that, right? We can also change it. Okay. So now let's print off. I'm going to say here, well, we got all the cool hair. Let's print off. I'll say here, Vencabot.inPockets.append, Nintendo DS. Right? Because Vencabot's a scrub. He carries around a DS instead of a PSP. Right, so now we're going to print off, what Kenny has. Kenny.inPockets. We'll print off Signopt.inPockets. And we'll print off Vencabot.inPockets. Right, so we'll print off all their inventories. Right, so what should we see here? We should see that Kenny and Signopt have sunglasses, a comb, a picture of their girlfriend, and a black leather wallet with a chain. And Vencabot should have all those things plus a DS. Right, let's run it and see what happens here. Holy fuck! Wait a minute! They all have the DS. But right here we saw that we can make Vencabot's hair uncool without affecting the other ones, right? So both Kenny and Signopt still have cool hair, even though Vencabot's hair was made to be uncool. Here we append a DS to Vencabot's pocket, but everybody got it. Why is that? Right? Well, because in the case of the has cool hair, we reassigned that name to a new value. Right? In this case, we simply took that existing list and appended a DS to it. And that list was defined right here at the class level. Right? So when this class was defined, when Python went through it and decided how a class should work, it read all this code and decided how it should work, right? It made this list, right? Made this list, and it gave this list to all things of that class. So this list belongs to Kenny and Signopt and Vencabot, right? Just like this value true belongs to Kenny, Signopt, and Vencabot. I'm gonna make some notes right here, in fact. When a class is defined, the class variables, so the values of the class variables are created. Every instance of that class has access to these values through, the name of the class variable. Right? So, every instance of cool guy has access to this true. Every instance of cool guy has access to this list, or to this list, right? Okay, so immediately, I'm making a note right here, right? Immediately, it's important that we understand mutability. It's important that we understand that this true and this list are shared among all instances of cool guy. That's what a class variable is. You make this name that's assigned to every instance of that class and to the class itself. And it gives all these classes access to the same value. Okay. So here we define some cool guys. Here we'll say we are overwriting the name Vencabot.hasCoolHair with a brand new value. We are not changing, we are not mutating any existing true to false. We are just replacing the name Vencabot.hasCoolHair with false. Right, there we go. So, right here, I'm going to say, make a note here. both Signopt and Kenny never replaced their reference to the original true. Thank you, Zanzu. Zanzu's the bot for our channel now. So, Kenny.hascoolhair and Signopt.hascoolhair still point to that original true. Right? Now, here's where things get crazy. This line of code does not create, reassign any names, right? Does not reassign any names, nor does it create any new lists. It takes the list that Vencabot.inPockets refers to and adds a new value to it, to that list. Right? Remember that Kenny.inPockets, Signopt.inPockets, and Vencabot.inPockets all point toward, are all names, right? They're all names that point toward the same list. Right? So we're talking about mutability here, guys. That's where things get kind of weird. Right? And once you understand the way naming works, it totally makes sense. And the way scoping works totally makes sense. Right? So again, just a review here, guys. We made a class. And when that class was made, we defined these two values. A true, that's a Boolean. We made a Boolean true. And we made a list. And every time a class is instantiated from this, every time an object is instantiated from this class, it has access to these two values. The true that we made and the list that we made. Right? So here, we reassign this name. You see that assignment, the little equal sign there? We reassign this name for Vencabot. So he no longer has access to that original true value, right? He reassigned his name entirely from from what it was to now hascoolhair equals false. Okay. So now when we say here Vencabot.hascoolhair, I'm gonna say here, this first line does not point to the value that was defined by the class. It points toward the value. We reassigned this name to a new value. Right. Both of these lines point toward the same value that we that was defined in the class, right? We never reassigned these names to point to anything else. Right? However, when we append this value, the Nintendo DS, to Vencabot.inPockets, remember that Vencabot.inPockets points towards this list. Right? And that list is shared by every member of this class. Right? So when we append a value to it, all of these names still point to the same list. Right? They're just names. They're all names of the same thing, which is this list we defined up here. Right? So when we appended this thing to it, it's reflected when we dereference all these names. Right? Sweet. Great. Let's fix the problem now. I'm gonna copy this code and make this, put it into our notes here. Okay. Sweet. Lots of notes today. There you go. Write it. Let's delete all this shit. Excuse me. All this, I don't want to be Don't mean to be vulgar. I meant all this fucking garbage. So you all this fucking garbage. And now we're going to say, let's fix our cool guy so that they all have unique pockets instead of sharing a single pocket. Right, make a new class here. Cool guy. Okay, and he has this has cool hair class attribute. It's true. All cool guys have cool hair by default. We're gonna say here def init self cool guy name. Right? Self.coolName equals cool guy name. And self.inPockets equals sunglasses, comb, picture of girlfriend, and black leather wallet with a chain. Gotta have that. Can't be a cool guy without it. Let's get to some a hang indent here, right? Pep 8. Pep 8, gentlemen. Here we go. Okay, so here's this list, right? Now let's do the same thing we did before, right? All the same code as before. I'm gonna say here, Kenny equals cool guy. Kenny. Signopt equals cool guy. Signopt. Vencabot equals a cool guy. Vencabot. We're gonna say here, Vencabot.has cool hair equals false. We're gonna print off Vencabot.has cool hair. We're gonna print off Kenny.has cool hair. We're gonna print off Signopt.has cool hair. So what do we know right now, guys? We know that both Signopt and Kenny, their name has cool hair, their attribute has cool hair, points toward this original true value. Right? It points toward this value right there. And we know that Vencabot has cool hair was reassigned. Right? His name was reassigned to this new false value. But it does not change the fact that Signopt and Kenny, their names still both point toward true. Right? We're just reassigning this name, Vencabot has cool hair here. Now we're going to say Vencabot.inPockets.append the Nintendo DS. Let's print off Vencabot.inPockets. Let's print off Kenny.inPockets. And let's print off Signopt.inPockets. Right? So what did we learn last time? Well, we learned that if you have a list shared by all members of a class, then when you append to one of those lists, or one of those names, it should append to all of them, right? So they should all have the DS. Let's run it. Oh no! Only Vencabot has the DS. Right? His hair is uncool. Their hair is still cool. He has a DS, they still don't have the DS. Well, what did we change? Right? What's the difference? So before, Vencabot.inPockets and Kenny.inPockets and Signopt.inPockets pointed toward this class variable. InPockets equals, sunglasses, comb, picture of girlfriend, and the black leather wallet with a chain. Right? So before we made this list, this list was created when the class cool guy was defined. Right? And this list is shared among every member of that class. Right? This list right here belonged to everybody of this class. Right? That was the old way of doing things. But now we are defining this list, and we're defining it on instantiation. Here's the init function, right? So whenever a new instance is created, we define a new name, self.inPockets, and we make this list. Right? Every time an object is instantiated from this class, init is run, and this list is created. Right? So this is not the same shared list for all of these instances. This list is created every time an instance is made. Right? It's a matter of scope. It's a matter of scope. Right? This list exists within the function init. Whenever init is called, this list is created. I'm going to actually put this on another line here. When the function ends, I'm going to make a note here. This is actually pretty interesting right here. This is really important. It actually deserves being down here. We discussed before. Yo, Mexi, you're so close, dude. What's up, Mexi? Hope you're having a good day today. We discussed before that when a name and data is assigned, when name and data is assigned to, within a function scope, right? That name and data ceases to exist once the function ends. Oh, thank you, Mexi. 7 months. Yeah, we're there then, right? I think so. Hopefully that number gets updated here in a second. Thank you, Mexi. Yeah, I mean, maybe even next week, dude. Pizza and a movie? What should we watch? Amazon Prime. Sweet. 7 months. That means you're only 1 month less than... Hey, we reached the goal. Let's fucking go. Let's fucking go. That's amazing, dude. That's amazing. I'm so happy. I love Pizza and a Movie, guys. If you guys are not familiar with the channel here, sometimes on Fridays we run Pizza and a Movie, and we watch like an old public domain film and eat pizza, and it's always a good time. Old black and white movie of like a horror movie or a drama or even a comedy next time. Who knows? Maybe we can do anything we want. If you guys don't remember, Amazon Prime gives you a free sub every month on Twitch. You have to remember to renew it manually. It kind of sucks. It doesn't auto-renew, but it is very helpful to streamers. Thank you, Mexi. Too strong, bro. Too strong. So we learned that when a name and data is assigned within a function scope, that name and data both cease to exist once the function ends, right? However, we learned that when you supply a mutable object as an argument to a function, you can make changes to that mutable object that are persistent outside of that function. Well, guess what, motherfuckers? Self is a mutable object, right? So methods of a class, as you guys know, if you guys watch Python or otherwise, programmers in Python, you know that methods of a class always take self as their first argument. This is exactly why, right? Self is a mutable object. So we can make changes to self, such as adding new attributes to it and adding values to those attributes. And those changes will persist once this function init ends. Right? So init is a function. This is a functional scope. However, we are making changes to self. Now, if we weren't making changes to self, this list would vanish forever. Right? We're making a new list here, and it would vanish forever. However, we are making a new list every time we run init inside the functional scope, but assigning this new list that we made to an attribute of self. So now we have this reference to this thing that we made inside the scope. So basically, every time init is run, we make a brand new list, right? Because it's inside the functional scope, it's a new list. And we assign it to this value, self.inPockets. So basically, this list that we made lives on as an attribute of self. So it is different from having it be a class attribute, because in a class attribute, this would always point toward the same list. Vencabot.inPockets, Kenny.inPockets, Signap.inPockets would all point toward the same list. But by putting it inside of a init instead, we're making a new list every time with all the same stuff in it, though. It's all the same stuff, but it's a brand new list. And we are assigning it to this mutable object self. Right? So that's the difference here. So before it was a class variable, and it was shared among, this one list was shared among all instances of that class. Now it's a instance variable, an instance attribute that is constantly recreated every time we instantiate a new object. Right? We remake this list every time. So now they all have basically copies of the same list. It is not the same list. It is a sort of copy of that same list. And now they can all be changed individually. Hence, appending the DS to Vencabot's pockets, it does not show up in Kenny or Signap's pockets. They have whole different lists. They're not the same list at all. Choco says, how would you do it if you want to exchange the pocket inventory between the players? Okay, we can do that. Yun says that Mexi's #1 stunner out here. What a savage. Yeah, Mexi's a young god, dude. Okay, so I'm going to make a note here. Let's copy this code. Let's just add it to the bottom here. Right, make a little note here. So, speaking of mutability and identity, right? And when I say identity, right, I'm talking about the difference between two different lists that contain, the same things, right? They might be, they might have the same stuff, but they are different lists. How can we move this list between, we'll say between objects, right? So we'll say here Choco Afro asks in particular how to share, how to exchange this pocket inventory between cool guys. Right. Well, if we understand the way that Python and other languages handles naming and identity, right? It's trivial. It's easy to do, right? We're going to say here, we know that Kenny.inPockets and Signap.inPockets and Vencabot.inPockets all point to different lists. We also know that we can reassign, names belonging to objects, belonging to instances freely. So let's give Kenny, the pockets that used to belong to Vencabot, and let's give Vencabot the pockets that used to belong to Kenny. Like this. All right, so we're going to say here, Kenny's old pockets equals Kenny.inPockets. All right, so what does this mean, right? This is kind of profound. This is why we're doing this today, guys. We're talking about things that seem simple, but are actually profound, right? So we're making a new name, right? Kenny's old pockets, brand new name. And we are assigning it to the value of Kenny.inPockets. I want to stress that now Kenny's old pockets is pointing to the exact same list that is currently named Kenny.inPockets. Right? We're making a new name, Kenny's old pockets. And we're assigning it to the value of what's currently named Kenny.inPockets. Right. So basically, we know that Kenny.inPockets is the name of a list. Right? Right? It's one name that belongs to a list. Now that list has two names. Now that list has two names. Right? Now we can access it by Kenny.inPockets or by Kenny's old pockets. Right? But now we're going to say here Kenny.inPockets equals Vencabot.inPockets. Okay. Now we have reassigned the name Kenny.inPockets to point toward the list that is currently named Vencabot.inPockets. Now the list at Vencabot.inPockets has two different names. Right? Those two names belonging to that one list are Vencabot.inPockets and Kenny.inPockets. Those names now point toward one list, right? The list that used to be pointed to by Kenny.inPockets now only has one name, Kenny's old pockets, right? So up here, we had this new name, Kenny's old pockets, and we assigned this name to this list that was at Kenny.inPockets, right? At this point, like we say right here, that list has two names, right? It was Kenny.inPockets and Kenny's old pockets. However, now we are reassigning this name, Kenny.inPockets, to a different list. We're taking it away from this old list and giving it to this new list, right? So now we're saying that the name Kenny.inPockets no longer points toward this old list. Instead, we are pointing it toward the list that's currently at Vencabot.inPockets. Okay? So what's left, guys? Well, we want to give Vencabot the list that used to be Kenny's pockets, right? So now we can just say here, Vencabot.inPockets equals Kenny's old pockets. Right? Now we have reassigned the name Vencabot.inPockets to point toward the list that is currently named Kenny's old pockets. Right? Now that list has two different names, Kenny's old pockets and Vencabot.inPockets. The list that used to be pointed to by Vencabot.inPockets now only has one name, Kenny.inPockets. Okay? So, at first, this can seem kind of confusing because you want to think of Vencabot.inPockets as a list, right? That's being changed or moved around. Actually, Vencabot.inPockets is just a name that we use to refer to a list, right? And that name can be reassigned to any other value, right? Yeah, once the name is reassigned, it no longer points toward its old value. Right? It can only, a name in a scope can only point to one value at a time. Right? So here, what we've done is all we've done here, right? All we've done is take two lists that already existed and we swapped their names. Right, that's all we did. So here we had, let's go over it one more time, guys. I put a lot of notes here, way more notes than code. It's only 3 lines of code, right? So we gave a new name to Kenny.inPockets. Right? We added the name Kenny's old pockets. So now this list has two names. Right? We added a new name to it. Then we reassigned one of the old names to the value, the list, that was at Vencabot.inPockets. Right? So now this only has one name. This list only has one name. And now this list has two names. Kenny.inPockets and Vencabot.inPockets. Right? And then finally, we reassigned the name Vencabot.inPockets to the list that's at Kenny's old pockets. Right? Now, why did we make a new name here? Kenny's old pockets. Well, because if we had reassigned Kenny.inPockets first, right, let's say we assigned the name Kenny.inPockets to the same list that was at Vencabot.inPockets, right? What would happen? Well, one thing that would happen would be that now this list has two names, just like now, it has two names. However, we would have lost every single name that we had to this old list. Right, I'm gonna make a note right here of that, in fact. Right. We have to create a new name for the list currently at Kenny.inPockets. Because on the next line, we reassign the name Kenny.inPockets to another value. Right? Because, without creating the name, without assigning the name Kenny's old pockets to this list, the next line would mean that the list now has no names, right? Because it only had one before. It had this one name here. Kenny.inPockets was that list, right? It pointed to that list. If we hadn't given it a second name here, it would only ever had that one name. Then when this name is reassigned, now it has no names. Once a piece of data has no names, there is no way for us as programmers to access it. That list is inaccessible, and Python deletes it. Garbage collects it to save memory. Let's see here. So Mr. N says, slightly pedantic opinion, but you should consider deleting Kenny's old pockets. Keeping multiple references to variables can lead to bugs if you forget about them. Multiple references to variables can lead to bugs if you forget about them. Mr. Anderson, I'm not sure I agree with that. I think you could delete it to save memory if you wanted to, I don't know. Why would you... I don't know. I'm not sure. I'm not sure that's super Pythonic, Mr. Anderson. Thank you for the advice, though. I'm not sure that's super Pythonic to delete it, just in case it might cause a bug by having that same name later on in your code. As long as you reassign the name, it should be no problem. Right? I can't imagine a situation where, I mean, it's not a part of an object. It's not an attribute. It's just a floating variable name, right? So I'm not sure how that could possibly cause a bug. If it was a part of an object, like an attribute name, that could potentially cause an issue in a remote situation. Anyway, welcome aboard, bro. Pleasure to have you. I'm not sure I've seen you in a little while. I've been gone at Michigan Masters for last week. There was no Intro to Python last week. Anyway, so that's why we made this name Kenny's, Kenny's old pockets, so that this list would have a name once we reassigned this one. Right? So now we have access to this list still, and we gave that to Vencabot, right here. So now finally, if we go down here and we print off, print Kenny.inPockets, and we print Vencabot.inPockets, we'll see that Kenny now has the DS. Let's run it. You see now Kenny has the DS right there. If you forget to reassign Kenny's pockets to Vencabot and try to use it to change Kenny, you end up changing Vencabot instead. If you forget you reassigned Kenny's pockets to Vencabot and try to use it to change Kenny, you end up changing Vencabot instead. No, I don't. Right? I just swap their lists around. That's kind of what we're talking about. We're talking today, Mr. Anderson, about understanding naming and understanding scoping and mutability. I feel like what you're talking about here is based on a misunderstanding of naming and mutability, right? The name Kenny's Old Pockets implies it's Kenny's pockets. Oh. Oh. Yeah, I guess, but that's really just, again, it's a throwaway. It's not Kenny.inPockets. I see what you mean, though. I see what you mean, Mr. Anderson. What you're saying is that, well, I mean, it's still Kenny's old pockets, right? They're still the pockets he used to have. Yeah, pedantic, yeah. If I could be equally pedantic, they are still Kenny's old pockets. Right? They're not Kenny's new pockets, they're his current pockets. They're still Kenny's old pockets. But now they're Vencabot's pockets. But yeah, I see what you're saying, yeah. Very pedantic. Okay, I'm sorry. So, yeah, that's how you would swap around their lists, Choco Afro. And all we're really doing, I really want to stress that as far as, conceptually, for us as a programmer, neither Vencabot, conceptually for us, Kenny has pockets and Vencabot has pockets, right? But as far as Python is concerned, that's not true. They don't own these values. They're just names, right? In the actual, deep in Python's guts, what you have is you have values and you have names for those values, right? So if you want to give Vencabot Kenny's pockets and vice versa, what you're really doing is taking those values, those two lists, and swapping their names, right? So those lists both still exist, but you're changing the names you're using to refer to those lists. Right? That's really all you're doing there. Now, I feel like maybe what your question was, Choco Afro. I really want to use that as a chance to talk about identity, right? About how I really want to stress that you have these lists, right? And they are their own thing, and they have names, right? So you can just swap their names around. That's how you would do that. But I think what you were asking was more like a game dev question. Like, how do we share things between these two guys? Which is not really a topic for today's conversation. But assuming that's what you wanted, I will demonstrate that real quick. Right. I have plenty of time left before we play our next game here. I might be wrong about that. It actually might have answered your question right there. But I think what you're really asking was, if we have these two inventories, how do they move things between them? Let's do that too, as our last thing for today. Right, and what we just did right there was totally swap their lists. Right, we gave Kenny access to Vencabot's pockets. We gave Vencabot access to Kenny's pockets. That's what we did. But let's instead have Vencabot give his DS to Kenny. Right, let's do it that way. See where all this code, it's quite verbose here, lots of notes. Let's get rid of it and make a brand new, much cleaner version of this. Okay. I'm going to say here, now let's have Vencabot's pockets stay Vencabot's pockets. And let's have Kenny's pockets stay Kenny's pockets. But let's have Vencabot give his DS to Kenny. Right? Why is this with this glowing line? Go away. Okay, so let's make a new class, right? Class cool guy. And we know that cool guys have cool hair. We know that when you initialize them, they take a name, a cool guy name. And we know that we save that name to the object, the mutable object self. We're going to save our name, right? Which means that now we can actually use it outside of the function. We're using this mutable object self to save these values outside of this function scope, right? Otherwise, everything that you name and create inside of a function goes away when the function ends. But in this case, we're using this mutable object to sort of get things out of here. We're actually changing self inside the function. All right, so now we have the cool name. We're gonna have a self.inPockets, and we know that it's got a comb. Excuse me, it has sunglasses, obviously. Has a comb. Has a picture of the girlfriend. And it has this black leather wallet with a chain. You have to have that. I can't stress that enough. Okay. Now let's make a few cool guys. We're going to say Kenny equals a cool guy with the name Kenny. We're going to have Signopt be a cool guy. Right, and he's Signopt. We're going to have Vencabot be a cool guy. He's Vencabot. Okay, so these 3 cool guys, right? Just straight chilling. Like cool guys are wont to do. But we're going to give Vencabot a DS. Vencabot.append, Vencabot.inPockets.append a Nintendo DS. Okay. Well, here, let me make a new, just to demonstrate things here. I'm going to, yeah, let's, talk about, I'm going to make another note here, right? And we're going to talk more about identity, right? It's so important. The theme of today is object-oriented programming, immutability, identity, etc. Let's, be this cool guy, right? We're going to make a class. We're going to call this, you know, pocket thing. We'll call this a pocket thing, right? And we're going to initialize it, self, and we're going to give it a thing name. Self.thingName equals, you know, equals thing name. And we'll say here self.thingName, we'll say self.engraved with. We'll say self.has stickers. Has stickers equals false. Has no stickers on it, man. Okay, so we have Vencabot, right? He has this DS. That's fine. Actually, I'm going to make these all things, pocket things. I'm going to make a pocket thing, sunglasses, okay? We have a pocket thing, comb. That's a thing name now, right? Comb. We're going to have a pocket thing, picture of girlfriend. Then we're going to have a pocket thing, black leather wallet with a chain. None of which have stickers, right? None of these have stickers. Why? Because when they're instantiated, their has stickers value is made false. Okay? They don't got no stickers, dude. That's fine. We don't want stickers, right? So we're going to append to Vencabot's pockets this DS. It's a pocket thing. Right. Well, we'll make a new DS here, right? We'll say, you know, Venka's DS equals a pocket thing, the Nintendo DS. I'll say that Venka's DS dot has stickers equals true. All day, dude. Give me those stickers. So we have this pocket thing we made, and the pocket thing's has stickers value defaults to false. Right? But we are reassigning that name to be true. So now this one pocket thing has stickers on it. You know what I mean? Let me plug in my iPad here, keep the chat open. Okay, that's really important that we do that. Okay, so now here's what we can do. Actually, I want to do it like this. I want to say append a pocket thing, the DS, right? Excuse me. Get rid of this line here. To make a new pocket thing, we're appending it to his pockets, right? Now we're going to say here, Vencabot.inPockets -1, the last item in his pockets, dot has stickers equals true. Okay, so now this DS he has in his pockets has stickers on it, right? But the reason I did that was so that we can point out that it only has one name. Right? The only way to access this DS is through Vencabot's pockets with an index. Right? It has no name otherwise. Okay, but it has stickers on it. That's great. So that's what we can do, right? Now we're going to say, okay, so now Vencabot has a DS in his pockets, and that DS has stickers on it. Right? Let's give it to Kenny. Right? Easy, right? Maybe. Maybe. So, now we're going to say, you know, we'll say Vencabot dot in pockets dot remove Vencabot dot in pockets -1. There we go. We just removed his DS. Okay, removed his DS. Good. Hey, thanks for the follow of Valton RS. We do Intro to Python here on creative streams on Fridays, like tutorial type stuff. I do creative tutorials here every Friday. Welcome aboard, homeboy. If you want to learn more about Python, check my YouTube channel at youtube.com/VencabotArchive, or just search on there for Vencabot. We have a lot of tutorials there for Python, more beginner stuff aimed at guys trying to learn Python as their first language, their first programming language, that is. Tell you how to download Python, how to write your first scripts, how to make games and stuff. It's pretty cool. I'm very proud of that channel. Anyway, so it's got a lot of gameplay on there too. Just ignore that stuff if you want to. It's an Intro to Python playlist on there. Anyway, so we have this. We removed the DS, right? We removed the last item in his pockets. We're removing the last item in Vencabot's pockets. Okay. Now we can say Kenny.inPockets.append a pocket thing to no DS. Okay. Now Kenny has a DS. But I mean, it doesn't have stickers. Right? Print it off. Print off Kenny.inPockets -1, the last thing in his pockets, dot has stickers. There you go. Let's run this code. Might be some typos in here, guys. I apologize. Might not run it at all. Run it. False. Okay, so here's what we did. We put a DS in Vencabot's pockets. Then we changed its value to have stickers. Okay. Now I want to give that same DS, right? And I'm talking about identity here, right? Identity. Now I want to give that exact same DS to Kenny. Now I've done that incorrectly here. I have removed that DS from Vencabot's pockets. And we have a problem. Our problem is that this pocket thing, this DS, only has one name right now. That name is Vencabot.inPockets SumIndex. Right? The only way to access it is through this inPockets object, this list. It has no other names right now. So when we remove it from that list, this thing is garbage collected now. That DS is destroyed. It goes away. So what we can do is we can append a new, we made a new pocket thing, we made a new DS, right? A lot of games will do this, and there's a time to do this. I want to point that out. It's not a bad thing to do. It's just that this DS we just made is not the same DS that was in Vencabot's pocket. So again, in certain games, you could simulate that. You could simulate it, oh, I gave you my DS, right? Here's mine got destroyed, you got a new one, but you could think of it as me giving you my DS, right? But I wanted to add this has stickers attribute to prove that it's not the same one. That's our problem, right? That's our problem. Now we could just, make this one have stickers too, but for the sake of argument, I want to really give Kenny the same exact DS that was in Vencabot's pocket. Right? How can we do that? Well, a few different ways. We can get this exact DS we made through the pop method of the list. Right? So what I can say here is instead of removing it, right? Let's get rid of all that stuff there. Make a new bunch of code down here. We can say here, instead of removing the DS from Vencabot's inventory, pocket, we'll say inventory, which gets rid of its last name, of its final name, and therefore causes Python to garbage collect it. We can use the list's pop method to remove the DS from the list and give it a new name, which we can then use to add that same DS to Kenny's inventory. Right, so we can say here, Venka's DS equals Vencabot.inPockets.pop. That removes the last item, I think, right? And we know the DS is the last item, right? We put it in his pockets. So now we have the DS, right? Now we can say here, Kenny.inPockets.append Vencas DS. We're talking about identity here, guys, right? So up here, we appended in a brand new pocket thing, a brand new DS. We made a brand new thing here. But here, we are assigning a new name to a thing we already had, which was Vencabot's DS, right? Now, it's no longer in his inventory. Please pop, that removes that. And we gave it a new name, Venca's DS. It's the same DS as it was before, but now it has a name we can access it by, right? So we're going to append that DS to Kenny's inventory, and now watch this. Now, it has stickers. You know, it's actually the same DS that Vencabot had, right? So we're going to say here, print Kenny.inPockets, -1, the last thing in his pockets, has stickers. Hopefully this works, guys. I'll be embarrassed if it doesn't. I've been doing a lot of typing. Might be a typo in there somewhere. True, right? So the last thing in Kenny's pockets does have stickers. The only thing we have so far that has stickers is Vencabot's DS, right? So we gave him the same exact DS that Vencabot had. It's a matter of identity, right? Instead of deleting the old DS and making a new one for Kenny, we actually removed the DS from Vencabot's inventory and gave that same object to Kenny. Right? That's why it has stickers on it, because only Vencabot's DS has stickers. Right? So what we've done here is, again, right up here, we removed the DS from Vencabot's inventory with the remove method. And because that DS had no other names, it got garbage collected. Right? We have no way now to access that DS anymore. We made it up here. It was created right here. And we gave it stickers right here, using its only name. Its only name that it had was an index in Vencabot's in-pockets list, right? As soon as we removed it from that list, right here, we lost its final name. We have no way to access it anymore. We can't get a hold of it anymore. Now it's garbage collected, it's gone. Right? We made a brand new one for Kenny. It has no stickers, very sad. Right? However, down here, what we did was we popped it from Vencabot's list, which will return it. Right? So it's a method that returns a value. So it returned that value of that DS, and we give it a new name, Venca's DS. So now we have a name for it. We can use that name to append it to Kenny's list. Right, now it's appended there. And now we can see that it has stickers. It's the same exact DS, right? We got it from Vencabot's list, gave it a new name, put it into Kenny's list. There you go. So that's how you would, that's how you would exchange an item between two inventories. Right? So in our first example, we gave Kenny Vencabot's pockets, we gave Vencabot Kenny's pockets. Right? We changed their list. We changed who owns them, basically, right, by changing their names. Here what we've done is we have actually taken an item from one list and put it into another list. Right? That's a whole different thing. Whoop-de-doo. Sweet. Guys, it is now 9:01. That was Intro to Python for today. Quite a rant there. It's kind of an interesting topic. It's sort of that's sort of like the ceiling between the intermediate level of programming and what's above it, right? It's this idea of understanding the way names actually work. You can get very far in Python. In fact, we've done 4 seasons now of our show, Intro to Python, and in none of those seasons have we ever talked about, the way that names really work, because they're really aimed at beginners, they're aimed at guys who have never programmed before. I don't want to overwhelm them, and so we've really just focused on, this is how you make a variable, right? But once you want to get above that level of, intermediate level programming, you're going to find that it's very important to understand the way that naming actually works behind the scenes, the way that identity works, the way that objects work, the way that mutability works, right? I hope that, whether it be, here live or on YouTube later, this helps somebody get a grasp on this kind of profound concept that can take some guys a long time to get a hold of. There's up WoWTech. Just in time for us to end the stream here and move on to some Cartoon Network Punch Time Explosion. We're a variety stream. We do Python programming a few times a week, and on Fridays, always from around 6 or around 9 p.m. Eastern Time, we do a creative stream where I do like a tutorial. I do a sort of like a lesson on Python or something else like that. Welcome aboard, Wawo. 6 is I found a couple of RPG creators. Nice, Signat. There's quite a few good ones out there. Good ways to make RPGs very easily. Okay, guys, so let's see here. I think that next week on Friday, we're going to, instead of doing a Python tutorial, I'm going to do some sound design tutorial, guys, using VCV Rack right here. Right. So in the past, guys, on every Friday, we've done an Intro to Python tutorial where I've talked about the basics of programming in Python. right? The basics of how do I make an object, what is data, how do I do operations, what is a function, and we usually start off very, very basic and get on to, by episode 6, the final episode of the season, we'll have a fully working game, right? A simple game, but a fully working game, right? So hopefully, my hope is that through the course of that season, we can take somebody who's never programmed before in their lives to being a sort of intermediate level programmer, right, over the course of a few hours. But today was sort of a side quest, not a part of any season individually. And next week, we're going to kind of take a step away from Python for a while and do some sound design instead. I'm going to teach you how to use VCV Rack to make your own kinds of sounds and stuff, like the music you're hearing right now. Can you tell me how can parameters, hinting, can help us? Yeah, Wabotech, sure. It's only there to help other programmers, Wabotech. So in Python 3, we added in this, I'm going to just copy this over the notes, right? It's really not the best time, but I've got time to knock this out, this question real quick. Okay, so let's talk about parameters real quick, parameter hinting. Can you teach data injection or design patterns? Not today, Jukebox. Welcome aboard, Jukebox. Welcome aboard, homeboy. That's a pretty broad topic. We're actually ending our stream here. So type hinting, right? Type hinting, the point of type hinting for parameters is just to help your fellow programmers. Thank you for the follow, Choco Afro. Help your fellow programmers understand how your functions work. For instance, let's say we have a function here that's, I don't know, it's called, add together. We want to add in, let's say you want to add, well, I always say here, like, print age. Print age, right? We'll have a person name. We'll have a person age, right? And we print off person name plus is plus person age plus years old. Right? Very simple function, right? Very, very simple function. We're going to say here, print David, they'll say Vencabot. And Vencabot is 32 years old. Thank you for the follow, Jukebox joined. So it doesn't matter, like, def bar int, and I use, like, floats as a parameter. Don't do that, Wabotech. So basically, the point of, it's a helper, Wabotech, but it's a helper for a reason, right? It's your instructions on how to make their program. So basically, if you're using somebody else's code, and they have a type hint there, that means that if you use a type other than that type, it's possible that it'll cause bugs, right? Always follow the type hints, right? Always follow them. Anyways, we have this this function, print age, takes a name and an age. It prints off their name, their age, and they're that many years old, right? Well, let's run this. Should be easy, right? Should be easy, no problem. Oh, that shouldn't have worked. What? Oh, I'm sorry. I printed it off wrong. I'm sorry, I printed it off wrong. I wanted to actually use print age, person name, and person age. There we go. There's our function. We're calling our function, right? This is gonna crash. There, it crashes, right? Oh, I'm sorry. I shouldn't have crashed that way though. I have to save the data. I'm sorry. I'm stupid. I'm gonna give this Vencabot and a 32. This is gonna crash with a some kind of type error. There you go. Run it. Type error, right? Can only concatenate strings to strings. So here I have a person name and a person age. So I reasonably assumed that I could enter a name and an age and it would work, right? You would think that from the name of it, but it doesn't work. Why? Well, because it assumes that person age is also a string, right? You cannot add strings to integers. So it causes a bug here. Well, the right thing to do would be to name this better, but instead we're going to use a type hint. I'm going to say here that person age is, person name is going to be a string. And person age is also going to be a string. Okay, now, does that actually do anything? No. It doesn't do anything. It doesn't fix any, it doesn't solve our problem at all. It doesn't solve our problem at all, really. But what it does do is it tells the programmer that follows me, if we're working at a team, right? If we're working at a team, it tells the person that follows me that I want a string here, right? If you don't put a string there, it's going to cause a bug, right? That's really all it's for. It's for communication. It's for communicating. So now I can read this and go, oh, it wants a string. Oh, okay. Okay, I can just do like this then. There we go. Now it should work, right? Okay, now it works. So it's really only there for communication, guys. And like Wow pointed out, you can also specify a return value, none, in this case. That way we know what's being returned right off the bat. Now, it's really more useful in situations where you have very long, complex functions. This is kind of a very simple example, right? I could tell it needs a string. I can see it right there. But if this function was 100 lines long, then it might make sense for me to figure out on the first line what kind of arguments I need and what the return value is. That way it's very simple for me as a programmer to understand how to use this function. Right? But yeah, if it has a hint, always obey it. Now, this is not a guarantee, right? This is not a guarantee it's going to crash, right? But it is saying that this function is designed to take a string. And in your case, Wowotech, that function is designed for an integer, right? Don't give it a float. It might work with a float, but don't assume it'll work with a float. If it wants an integer, then give it an integer, right? Always follow the type hints if possible. All right, guys, I'm going to move on to our next show here. Guys, as usual, if you guys enjoy hanging out, want to keep the channel on, then check my Patreon page, patreon.com/Vencabot. I stream for 40 hours a week, every single week. It's a lot of work, man. It's a lot of work. It's pretty exhausting. When the stream ends, we're going to stream all night long. The stream's kind of like my whole life, guys. I upload stuff to YouTube all night. I do things like getting the next game set up. I was testing a PS3 game last night for today. I do things like Patreon stuff and social media. It's kind of exhausting, but it's also very rewarding. If you're like me, maybe you want to help out financially, you really can't afford to, that's perfectly fine, guys. In fact, the best way to help out is, free. Get in the chat, come say hi, keep me awake, follow on Twitch, tell your friends we're here, check out YouTube at youtube.com/Venkabotarchive, or just go to YouTube and search up Vencabot. You'll find me that way as well. I've got lots of programming tutorials over there for Python, for total beginners to intermediates. We also have other creative stuff. We've got other long plays, video games, fighting games. It's a new video every single day on YouTube, man. I put a lot of work into it. I'm going to go on a very short break, guys. Come right back with some Cartoon Network Punch Time Explosion on PS3. I'll see you guys very soon. Does it pops out the hint on IDE? Yes. Exactly, Wowotech. It should. Maybe not every IDE supports it, but every IDE should support it. That's kind of the idea. But I can't guarantee that your IDE will. But most IDEs for Python should warn you about type hints. I mean, there's not a whole lot you can do, right? There's not a whole lot you can do. You have to gamble against Alex and Hugo. And other characters that are command grab centric. Here we go. Oh my god! Yo, my god. Who's clipping? We'll do, Anderson. Actually, are you on our Discord, Mr. Anderson? Me and Kenny recently did a very short lesson on decorators on Discord. It's available on the Intro to Python channel at Vencabot.com, which is where our Discord is at. But I'd be happy to go over that on a future stream. Yeah, thank you for your help, Signop. Those designs are really sick. Let me upload some stuff to GitHub here. You guys want to read our previous lessons and stuff and keep up with us? Again, that's all on YouTube at youtube.com/VenCabotArchive. We've got all of our past lessons there. We got 4 whole seasons of Intro to Python. Teach you guys how to make games over there. Simple games for beginners.
Jesus Christ.
But we also have other notes and stuff. That's at github.com/Vencabot. Good stuff, Mr. Anderson. Hey, up, KD. Yo, fucking KD. Cartoon Network Punch Time Explosion, bro. Who should I play as? It's gonna get real. A little bit of saying you gotta come to me.
Oh, the dancing. What?
Nice careb.
Oh
my god! Combinations? Just like Steph, don't talk about the flippers, dude. That's insensitive. Look, Crime Alley. Back at it, dude.
Crime.
Right back to
You
it.
played
Come on.
I was like, who knows? You know, maybe he'll do all right. I don't know. I mean, did the state of Minnesota really suffer under the reign of Jesse Ventura?